Good morning, dear students. Today I am going to start the 8th standard, the third chapter, Chemistry, Metals and Non-Metals. So in this chapter we are going to discuss about the physical and chemical properties of metals and non-metals. What is the difference between the metals and non-metal we are going to discuss. So metals have few properties and the non-metals does not have these properties. The metals have the special characteristics. See, if we want to see the properties of the metals and non-metals, we can see these special features of the metals. The metals have these special features such as metals appear in golden or silvery grey color, and they have the lustrous or shiny surface, and they are hard in nature. They are hard in nature and they are available in solid. Most of the metals are available in solid. Then they have the special properties like malleability, ductility, sonorous, good conductor of heat and electricity. So these are some of the these are the main features. These are the special characteristics of metals. Now let us learn about this property. What does it mean? What do you mean by malleability? What do you mean by ductility? What do you mean by sonorous? And all these properties with the activity. So the first property I am going to discuss about the hardness and appearance. So when you see the iron material, the pure iron material surface is dull or shiny. Yes, they are shiny in appearance. They have the shiny appearance. You can make out. It is available in silvery grey color. Then what about the hardness? Can you easily break using the scissor or using the knife? Is it possible? No, you can't break easily the iron material. It is so hard. So it is very hard. And take the next material, aluminium metal. Okay, aluminium. When how does it appears? If you have any aluminium vessel, the new aluminium material, it will be how it looks. It have the shiny appearance. It have the shiny appearance and it have the silvery grey color. It is available in silvery grey color. And then is it easily breakable? No, it's not easily breakable. It is also hard. You can't easily break this material. And then next one is copper. Copper, what is the color of the copper? Yes, color of the copper is similar to gold. So its color is similar to gold. And it have the shiny appearance. You can see you have so many materials in your home. So it also have the shiny appearance. It is hard. It is also not easily breakable. It is also hard material. The next one is sulfur. What is the color of the sulfur? Sulfur is lemon yellow in appearance. Okay. Then what about the hardness of it? Take the hammer and try to break it. Okay, is it you can easily break, or using the scissor or using the knife. If you try to break, it is easily breakable. It is soft. And then next one is coal. Coal is appear in black color, right? Coal is appear in black color, and then using the knife or using the scissor, you can easily break. It is also soft. So in these materials, iron, aluminium, copper, they have the shiny appearance and they are hard in nature. So these materials are, these three, iron, aluminium and copper, are metals. These are metals and these are Non-metals. These are non-metals. Got it? So we have classified based on the appearance and hardness into two types. They are metals and non-metals. Metals have these property. They are shiny in nature and they are hard. Okay, take these. Now I am going to explain the one more property of metals. So to understand this property, what you have to do, you have to take these materials, iron, nail, aluminium, coal and sulfur, or any other materials also. Okay, iron, nail, aluminium, coal, sulfur and all. And also you can use the copper materials and all. So take these materials and try to hit using the hammer. So when you hit the iron nail using the hammer, what happens? The shape will be changed. The shape of the iron nail will be changed. Then if you take the aluminium metal, an aluminium vessel or aluminium sheets on the, if you hit using the hammer, it also changes its shape. Then if you take the coal, take the piece of coal and hit using the hammer, it will be easily breakable and it will become the powder form. You will get the powder form of it. It will be breakable into small pieces. Then sulfur also you can break them into small pieces. You can't get there is no change in the shape, but it will get the powder form. You will break them into small pieces. So that property is nothing but malleability. So what do you mean by malleability? When you hit the metal, it will be it changes its shape and you can make them into thin sheets, right? If you go to any restaurant or hotel, okay, if you want to buy anything, they will say they will give the parcel in the aluminium foil, right? So aluminium foil, they are available in how it looks. It is a surface. It is very thin sheets. So aluminium, copper, or in your home also they will use the sheets, right? Iron sheets. So you can make the metals into thin sheets. You can by hitting using the hammer, you can change the shape of the metals. So they are available in thin sheets. You can make them into thin sheets. Iron nail also can be converted into thin sheets. So that property is nothing but malleability. Malleability is nothing but changing the shape into thin sheets. Okay, the next property is ductility. So when you hit the metals, before that, which metal in your home you have the cable connection and all, the electrical wire connection and all. Inside the wires, okay, inside that cable wire, there is thin wire, right? So which metal is used to make that wire? So which metal is there inside that cover? Yes, that is made up of copper, right? The electrical wires and the cable wires, inside the cover there is a metal. That metal is nothing but copper wire. Copper is the metal used to make the electrical wires. So we can say that when you hit these metals, you can make them into thin wires. So these metals, you can make them into thin strips, thin wires. So that property of metals is ductility. You can change the shape of the metals. You can make them into thin wires. That property is nothing but ductility. So we can see in metals there is property of ductility, whereas you can't make the thin strips. You can take the coal, or if you take the sulfur or any non-metals, you can't make them into thin strips. you can take the eraser also. Can you make them into thin wire, or can you make them into thin sheets? No, right? Because it is a non-metal. Or the coal also, if you hit, it will become the powder form. So there is no they don't show the property of ductility or malleability. Then the next property is conduction of heat. Okay, for the electrical wire or for the cable connection and all, which material we use, whether it is a metal or non-metal? Yes, we use the copper wire, right? So that copper wire is a metal. Or if you want to cook anything, if you want to cook the rice, if you want to cook any dishes, we use the metal. We use the metallic vessels such as copper vessel or the aluminium vessel. We don't prefer that non-metals. We don't use the wooden material, because they are not they does not conduct the heat. We use a material made up of metals, copper, aluminium, all these are the metals, because they conduct the heat. So we can see the conduction of heat. We can see this property of conduction of heat in the metals. And when you see the handles of the cooker or the pan, they are made up of which material? Is it a metal or non-metal? Or if you take the while cooking, while boiling anything, okay, if you touch the handle of the cooker or any vessel handle, will you feel that heat? No, you don't feel the heat when you touch the handle of the cooker, because that handle is made up of non-metals. Non-metals does not conduct heat. Only the metal particles, only the metals conduct the heat. So that is a speciality of these metals. And there is also conduction of electricity. What do you mean by conduction of electricity? The electrical wires, cable wires are made up of the metals, because they conduct the current. So inside the cable, inside the electrical wires, there is a metal, because they conduct the current. We don't prefer the non-metals. They are made up of metals such as copper, aluminium and all. So, and when you touch the switchboard, in the switchboard, when you touch the switch, you will not get the shock, electrical current. You won't feel the electrical current. Why? Because they are made up of electrical switches. Switchboard is made up of the non-metals. That material is non-metal, because non-metals, and these non-metals does not conduct electricity. So that is the difference between metals and non-metals. Take a piece of iron and one non-metal like eraser or any coal piece and all. Try to hit on the surface. So in which case, when you hit the surface, which case you will get the sound, which makes the ringing sound? Iron material or the copper material or the aluminium makes the ringing sound, right? When you lift the aluminium vessel or the copper wire, and when you place it, you will feel the sound, right? After few seconds you will hear the ringing sound. Or in the holy places, they use the bell. In the temple, in the church and all, they use the bell. So that also makes the ringing sound, because that is why they prefer that metal in the for the ringing sound, right? So that property is nothing but sonorous.
A number of metals such as zinc, copper, aluminium produce sound when tapped with a rod or when dropped on the floor. The sounds are different for different metals.
What do you mean by sonorous? Sonorous is nothing but it is a property of metal which have the ringing sound. When you hit the metals on the surface, it creates a ringing sound. That property is sonorous. Metals show this sonorous property. And what about the non-metals? If you hit, take the rubber or the wooden piece, and if you hit on the surface, will you get the ringing sound? No, because it is a non-metal. Non-metals does not show the ringing sound, does not show this sonorous property.
When scientists were discovering elements, they felt the need to group these elements. It can be done by grouping these elements by studying their physical and chemical properties. Let's try to understand some physical properties of metals and nonmetals. Luster. All metals in the pure state have a shining surface. This property is called metallic luster. Nonmetals, on the other hand, are dull. Therefore, they do not have luster. Hardness. Try to cut iron with knife. Isn't it very difficult? Why? Because metals are hard. Now try to cut a rubber with knife. It must be very easy. Thus, nonmetals are soft. Malleability. Let's perform an activity. Take iron nail, coal piece of thick aluminum wire, pencil lid. Beat each of them with a hammer. What do you observe? Iron nail and aluminum wire change their shape, but coal piece and pencil lead break into pieces. Harder we beat, greater is the change of shape. Thus, metals, if beaten, change their shape and forms thin sheet on beating. This property is called malleability. Nonmetals break into pieces like we have seen in activity. Ductility. Another interesting property of metals is the ability to form thin wires. It is called ductility. With this property, you can see wires of aluminium, copper, iron. Nonmetals do not show this property and breaks if we try to form wires. Sonority. The property of producing ringing sound when a substance is struck by a hard substance is called sonority. Metals are sonorous, but nonmetals are not. Conduction of heat. If one end of iron rod is heated, then we can feel rise in temperature at other end also. This means that metals conduct heat. Nonmetals does not conduct heat. If nonmetals would have been conducting heat, will it be possible to use them as handles for cookers and pans? No. Conduction of electricity. Let's perform another activity. Connect circuit as shown. Check if the bulb lights or not. Repeat the same for other materials. Observation, material and conductivity. Iron nail is good conductor. Sulfur is bad conductor. Coal piece is bad conductor. Copper wire is good conductor. From this activity, You can verify that metals are good conductor of electricity, but non-metals are bad conductor of electricity.
Okay, till now we have discussed about the different properties of metals. The properties which I have discussed till now are the physical properties of the metals. Which are they? Can you list out the properties? Yes, they are. What about the appearance? The metals are shiny. They are available in golden yellow color or in the silvery grey color. The next property is metals are hard, whereas the non-metals are soft. Then metals show the property of malleability. What do you mean by malleability? Yes, you can change the shape of the metals into sheets. You can make them into thin sheets. That is a malleability property of metals, whereas you won't get the thin sheets of coal, sulfur or piece of rubber. The next property is ductility. What do you mean by ductility? Yes, when you hit the metals using the hammer, you can make them into thin wires. Copper wire, then aluminum wire. These are available in thin strips. They are available in the form of wires. So you can convert the metals into wires. That property is nothing but ductility. The next property is, which are the good conductors of heat? Yes, we know that metals are the good conductors of heat. How do you come to know? Because we use the material which is made up of metals such as copper vessel, aluminium vessels and all. They are good conductors of heat. The next property is good conduction of electricity. Which are the good conductor of electricity? Yes, the metals are the good conductors of electricity. We in the electrical wires, electrical cables, in the telephone cables and all, we use the metals. We use a wire which is made up of metals. They are the good conductors of electricity. The next property which I have discussed is sonorous. Which material shows the sonorous property? Metals show the sonorous property. When you hit on the surface, the metals makes a ringing sound. That ringing sound is nothing but property of sonorous. So metals show the property of sonorous, whereas the non-metals does not show the property of sonorous. Okay, till now we have discussed the physical properties of metals and non-metals. Now let us discuss about the chemical properties of metals and non-metals. Why we have to consider this chemical property of metals? Because there are few
Exceptions. Sodium and potassium are soft and can be easily cleaved, that is, cut to form plain surface by knife. However, these belongs to metals. Similarly, all metals are solid except mercury, which exists in liquid form. Iodine is a non-metal, but it is lustrous. Diamond is hardest substance, which is a non-metal. What this means is that we cannot classify substance as metals or non-metals only on their physical properties. To classify, we have to study their chemical properties as well.
As I told, the metals are hard in nature. But if you see, there are few exceptions. The metals such as sodium and potassium, they are not hard. You can, if you break them using the knife, you will make them into, you can break them into simple pieces, small pieces. So they are not hard. They are easily breakable. So this is one exception. And as I told, the metals are solid in nature. Most of the metals are solid in nature. But there is one exception. The metal, that is mercury. Mercury is the only metal which is available in liquid state at the room temperature. Mercury is available in the liquid state. Mercury is only the one metal which is available in liquid state. You should remember this concept. As I told, the non-metals are soft in nature. But if you consider the example of this diamond is a form of one form of carbon. Okay, it's a form of carbon, and it is a non-metal, but it is the hardest substance in the nature. Diamond is the hardest substance in the nature, and it is a non-metal. So these are few exceptions. So in order to understand the properties of metals and non-metals, we should learn the chemical properties also. So now let us discuss about the chemical properties of metals and non-metals. So the first concept is reaction with oxygen. How does the metals react with oxygen, and what about the reaction of non-metals with oxygen? Let us understand this through this video.
Dad, why has this iron rod turned like this?
It's rusted. Iron reacts with atmospheric oxygen and moisture to form iron oxide, which is commonly known as rust. Metals react with other elements in a variety of ways. Metals burn in the presence of oxygen to form metal oxides, which are basic in nature. For example, if you burn a strip of magnesium, magnesium will burn in oxygen to form magnesium oxide. Magnesium oxide dissolves in water to form magnesium hydroxide, which is basic in nature. Similarly, when a copper vessel is exposed to moist air, a green coating forms on its surface. The coating formed is a mixture of copper hydroxide and copper carbonate.
At last, I found them.
What are these? Oh, iron nails.
These nails got rusted too.
Yes, the nails have rusted because of the moisture present in air. Metals react with water, but all metals do not show the same kind of reactivity. For example, sodium reacts vigorously with water and oxygen and produces so much heat that it catches fire. That's why sodium is stored in kerosene to prevent it from coming into contact with moisture and oxygen. Let's try an experiment. Take a trough. Fill half of it with water. Now carefully cut a small piece of sodium and dry it using a filter paper. Then wrap it in a small piece of cotton. Place the piece of sodium in the water trough. You will observe that sodium reacts vigorously with water, catches fire, and moves about in the water, making a hissing sound. So now you understand how much heat is produced in the reaction. When you introduce a red litmus paper, it turns blue, indicating that the solution formed is basic in nature. Be careful. You should stay away from the water trough during the reaction. It gets very hot.
What are you doing here, Father?
I'm cleaning this tap with a lime peel. The tap is looking dull because of the deposits of calcium salts in water.
Ah, the tap is shining now. How did that happen?
Lime juice contains citric acid. Acids react with salts of metals. The citric acid of the lime juice reacted with a calcium salt on the tap, and now the tap is clean. Metals react with acids such as hydrochloric acid and sulfuric acid to give out hydrogen gas. Let's take 4 different metals, magnesium, iron, aluminium, and copper in 4 different test tubes A, B, C, and D respectively. To these test tubes, we add 5 milliliters of dilute hydrochloric acid or sulfuric acid using a dropper. We can now heat the test tubes gently using a Bunsen burner. Hydrogen gas is liberated. But how do we know it's hydrogen? To test the gas, we introduce a burning splinter near the mouth of the test tube. The splinters put off with a pop. It shows that the gas is hydrogen. From this, we can conclude that metals react with dilute acids and liberate hydrogen gas.
Do metals react with bases in the same way that they react with acids?
Yes, the reactions are quite similar. Metals react with bases such as sodium hydroxide to produce hydrogen gas. Let's verify this with an experiment. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 or 4 ballots of it in 5 milliliter of water. Into this solution, drop a piece of aluminium foil. We now bring a burning splinter near the mouth of the test tube. The splinter is put off with a pop. This shows that hydrogen gas was produced.
In depth, the reactions of metals with acids and bases are quite similar. But, you mentioned that some metals, such as sodium, react more vigorously than others. How do you know that?
Let me show you an interesting experiment. Let's take 5 beakers A, B, C, D, and E. Let's take copper sulfate in beaker A and B, drop some zinc granules in beaker A and iron filings in beaker B. Take zinc sulfate in beakers C and E, drop copper turnings in beaker C and iron filings in beaker E. In beaker D, take some ferrous sulfate solution with a few copper turnings. Now note that the blue color of the solution in beaker A has disappeared. This is because zinc replaces copper from copper sulfate. In beaker B, the solution turned green. This is because iron has replaced copper from the copper sulfate solution. There's no change in the other 3 beakers C, D, and E. This brings us to the end of the detailed session on metals, their appearance, behavior, and uses in our day-to-day life. When you make a bonfire, the wood burns to release smoke. Nonmetals react with oxygen and form acidic or neutral oxides. For example, sulfur reacts with oxygen to form sulfur dioxide, which is acidic. Take a small amount of sulfur in a deflagrating spoon and heat it. As soon as the sulfur starts burning, introduce the spoon into a gas jar. Then cover the jar with a lid. To ensure that the produced sulfur dioxide gas does not escape, remove the spoon after some time. Add a small quantity of water into the gas jar and quickly replace the lid. Shake the gas jar well. Sulfurous acid is formed. Now introduce a blue litmus paper which turns red. The sulfurous acid turns the blue litmus to red. Observe the bonfire. Why? In this bonfire, there is a partial combustion. Carbon monoxide is produced. This is a neutral oxide. Nitric oxide is another example of a neutral oxide. We don't need the fire anymore. Let's put it out.
The fire is gone, but the unburnt charcoal is left behind.
That's true. Generally, nonmetals do not react with water, though they may be very reactive in air. Such nonmetals are stored in water. For example, phosphorus is a very reactive nonmetal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Yet, another important property of nonmetals is that they do not react with acids. Let's look at this small experiment. Take sulfur powder in a test tube. Add 2 to 3 ml of dilute hydrochloric acid or dilute sulfuric acid. There's no observable change. Unlike acids, bases do react with nonmetals. Reaction of nonmetals with bases is complex. For example, when chlorine reacts with a base like sodium hydroxide, it gives multiple products like sodium hypochlorite, sodium chloride, and water.
It was very interesting to learn so much about nonmetals. Now I will be able to identify the properties and uses of nonmetals.
What about the reaction of nonmetals with oxygen? Let us understand this through this video. Okay, dear students, in today's class we have discussed about all the physical properties of the metals and non-metals, and one chemical property of metals, that is reaction with oxygen, we have discussed in today's class. The remaining chemical properties of metals and non-metals we will discuss in the next class. Thank you, students.